Okay, hello everyone. So we're going to begin by giving a quick introduction to what iterators and what iterables are. Okay, so iterator, iterable, and then what is an iterator? Okay, so does anyone have any idea what an iterable is? How would you describe an iterable?
Something you can iterate over.
Yeah, exactly. So we can think about it as something to iterate over. Okay, so I like to think about if we have some object, let's say we create some object. Let's be more specific. Let's call it, I don't know. Let's call it some list object, okay? If I can use this fancy for loop on an object, it means that object is an iterable, okay? So let's say I do, I don't know, if I could do for int x in my list object, okay? This will only work if this list object is an iterable, okay? So that's what an iterable is. It's something that we can iterate over, and a special case of that is using this fancy for loop, okay? So the next question you guys would probably ask is, how does a class define itself as an iterable, okay? The answer to that is you want to implement the iterable class, okay? The iterable interface, okay? And then you'll specify the type for what types of objects that you'll be iterating over, okay? So in this example, if we have some list object class, it'll probably be implementing iterable, and it'll take in some integer as the type of object for the interface, okay? Now, in order to be an iterable, the iterable interface specifies one function, okay? That function is an iterator. It returns an iterator, okay? So in order to be an iterable, we need to define a function that returns an iterator, okay? So this is kind of messy. I apologize. To be an iterable, we need to return an iterator, okay? So the next question that probably arises is, what is an iterator, okay? An iterator is some object that allows us to iterate over some sequence, okay? So an iterator is some object that iterates, okay? So in order to be an iterator, we have to implement two methods, okay? So the two methods we need to implement are hasNext and next, okay? So that's like a very high level overview. So I'll give you guys like a quick gist, and then we'll get started with problem one. In order for a class to be an iterable, it needs to implement a method that returns an iterator. In order to create this iterator, what's often the case is you'll have a private class that creates or that implements iterator, and then that class that implements iterator will create two functions, hasNext and next, okay? And if this doesn't make a ton of sense right now, that's totally fine. We'll start with the first example, and hopefully that'll clear things up. Okay, so let's look at this first example, filtered list. And we're not going to like talk about iterators in like really difficult contexts. For like the midterm, they aren't going to be emphasized like greatly, but it's good to know what they are. Okay, so for the first problem, we want to create a filtered list class that is an iterable, okay? So I'll emphasize that. We want to create a filtered list class that is an iterable. In order to make something an iterable, it needs to define this function iterator, okay? So a filtered list takes in a list as input, and it produces an iterator that spits out all of the values in the list such that test of that value is true, okay? So let's say that we create some filtered list that takes in the array 0, 1, 2, 3, and let's say my test function is odd, okay? What'll happen is if we iterate through our filtered list, we will spit out the values 1 and then 3. Okay? Does anyone have any questions on what filtered list is? What the question is asking? Okay, I'll give you guys around 5 minutes to go for it. Okay, so let's quickly walk through the solution for filtered list. Okay, so what do we have to do here? Filtered list should be an iterable. In order to make something an iterable, it must implement this method that I highlighted in green. Okay, so this method should return an iterator that will spit out the values where test of that value returns true. Okay, so we don't have that iterator, so we have to create it. Okay, in order to create that iterator, what we do is we create a private class filtered list iterator. Okay, this private class filtered iterator will implement iterator, and we want to use generic, so we'll do iterator of t. Okay, so now the big picture is we create a private class that implements an iterator, then we return an instance of the iterator. Okay, so that filtered list is now an iterable. Okay, so this is the instance that we're returning, and we create this instance by defining this private class right here. Okay, and in order for something to be an iterator, it has to define 2 functions, has next and next. Okay, and I think they're pretty intuitive on the definition. So let's just get started by writing the code. Okay, the first thing that we want to do is in the constructor, we probably want to take in the list and the predicate and store it as some instance attributes, right? Otherwise, it'll get lost forever. So we can quickly create some list t. We'll call it list, and then we'll create some predicate t, and we'll call it filter. Okay, then we could say list is equal to L. I'm going to change the name so I can not have to use this. And then we'll say F is equal to filter. Okay, nice. So now we've kind of finished the constructor, nothing too complicated, I hope. The next thing that we want to do is we want to pass in the information of the list and this filter to our iterator, right? So what we can do is we want to pass this information. So we'll add it as parameters, the list, and then we'll also pass in the predicate, F, okay? Then right here, our constructor will take in the list, we'll call it L, and it'll also take in this predicate. I need to give myself a bit more space. Actually, let's make the variable naming a bit better. Let's call it big L, and let's say predicate. Let's call it, we can call it F, okay? So now what we want to do, there's many ways we can approach it. My idea is let's just create a new list that has all of the values in this list that predicate.test on that value gives us true, okay? So this solution isn't really efficient, but it's like very straightforward. The better way that you guys can approach this is by storing an index variable that tracks where you are in the list, incrementing that index variable as you move on. But this solution requires like a bit more effort, and I want to focus on like things later in the discussion. So that'll be included in the solutions. So take a look on the solutions if you guys had an implementation with some index variable that keeps track of where we are. But my idea is let's just create some new list. I know we can create some linked list. Let's call it list. And we'll say list is equal to a new linked list. Okay. Now my idea is we'll iterate through each item in our list L. We'll ask ourselves, okay, we'll say if f dot test, if f dot test on the item, right? Then we can just add it to our list. So we'll say list dot add item. Okay, so nothing too complicated. Now all we do is when we call next, right? I want to add a t here. Okay, so we can call hasNext by just returning whether our list, right, if it's not empty. Okay, so that's like a really easy implementation for hasNext, right? And then for next, all we have to do is return list dot remove first. Okay, so that's the solution. And does anyone have any questions? Oh, actually, wait, there's one more thing that we're missing. At the top, we have to implement iterable. Okay.
I had a question, actually, a couple. So does this mean that every time we want to implement iterator, we have to rewrite the hasNext and next methods? Like we can't have a default, right, for both?
Yeah. So there's no default implementation for hasNext and next.
But then what's the advantage to using iterable and iterator if we're gonna have to write a new method every time we implement it?
It's because, okay, can you scroll down? Yeah. Okay, so the reason is that it allows us to use a lot of cool features in Java. One such feature is now what we can do is let's create a filtered list, maybe of, I don't know, integers, right? And I can call that f. Now I can use an enhanced for loop and say we can just do for int I in f, right? Isn't that pretty cool? We can do that. Yeah.
It's just that in lecture he showed like the enhanced for loop, but there was the step before where we had to write like what was actually going on under the hood. And so my question was, how did we go from that to this? Like what did we do to get that level of abstraction?
Yeah, good question. So in lecture, what happened is we started off by implementing iterator, okay? After implementing iterator, we have access to hasNext and next, but we still can't do the fancy for loop on it. In order to do the fancy for loop, we have to implement iterable. And then once a class implements iterable, it has access to this thing called for each, and that's an operation where you can use a fancy for loop.
But the code is in the Java util iterable. We didn't see it.
Yes. It's all like abstracted away.
Yeah. Okay, cool. Thank you.
You're welcome. Any other questions? Yeah.
For 14, so it says private class filtered list iterator. How come like you didn't specify that it takes in a generic type, like the brackets T?
Yeah, so that's a good question. And the reason is because we have like the outside class takes in T, and when you implement like iterator, it's kind of confusing, but you don't actually have to mention it here. Yeah. Okay, so then it's like, it gets a bit confused on which T that we're using, because if I override the T in the private class filtered list, then it's like there's two T's, and it's like, which T am I actually using? You see? Okay, the idea is like, if I have a T here, then it's like, which T is actually getting called for this thing, right? It has no idea. So it's like, if we overly define the generic types, then we don't know which T we're actually accessing.
However, multiple types of T's again, like, isn't a linked list just like of one type? Sorry, I'm still a little confused.
Yeah. Okay, so like, if we have like two generic types, it looks like, okay, if I have T here, it'll be identical to the T up there, but that's not how Java looks at it. What that's saying is like, if we have, I don't know, a T down here, that's gonna be different than the T up here. And that's gonna produce a lot of complications.
Okay.
Yeah.
Okay, so generally you would just leave the T out.
Yeah.
In 14?
Yeah.
Okay, cool.
Okay. So I'm gonna like, okay, what's line 11 and line 12? Okay, yeah, so what's this override? Is that the question? So the override is because this iterator function is coming from the interface iterable. So in order to use it, it's good practice to add in the @override. So we make sure that we're overriding the proper iterator function from the class iterable. Okay. Okay, so if you guys have other questions, feel free to send them in the chat. But I want to move on to some dynamic method selection. Okay. So let me stop sharing from my iPad. Okay, so more practice on iterables. There's this entire worksheet. There's also the discussion worksheet, and both of those are good practice. Okay, so the first thing that we're going to be doing. Okay, so I have some questions, and this is just like classic dynamic method selection. Let me move you guys down. Okay, so I know a lot of people like had some questions on dynamic method selection, so I wanted to cover at least like 4 or 5, actually 7. Okay, so we have a class animal, class dog, class poodle, and then we create 2 instances, an object Soham and a dog Benel. Okay, and the question is, what will be the values for first, second, third, fourth, fifth, sixth, seventh? Okay.
Can you zoom in some?
Yeah.
Thank you.
Let me try to condense it a bit better. Sorry about that. Resume the recording. Okay, so I'm just gonna like quickly blaze through all of them, and then you guys can talk to me afterwards if you guys had questions. Okay, so the first thing we do is we create 2 instances, Benel and Soham, and I like to create them in a table like so, just so it helps me keep track. Okay, then we'll do benel.speak Soham. This is gonna throw a, let's see if I can draw, right? This will throw a compile time error because Soham's type is object, and we don't have any functions here that take in an attribute of object. Okay, so the next thing we do to address this problem is we cast Soham into type animal. Okay, what this does is for this function call, we're going to think of Soham as not an object, but of static type animal. Okay, that's what casting does. For this function call, Soham, you are now an animal. Okay, so what do? Benel is a dog. So we look in the dog class for a speak function that takes in an animal. We find one. During compile time, we lock in on this method signature. I often use this idea lock in. Lock in is my way of saying that the compiler chooses this exact method signature. Okay, so we lock in on this method signature. Then during runtime, we ask ourselves, can we do better? So Benel is a poodle. We look in the poodle class for the exact same method signature we locked in on during compile time. None exists, so we return 3. Okay, so the first one was a compile time error. The second one is 3. Okay, now it gets a bit trickier. This is very confusing for a lot of people, so try to pay attention. Benel.speakBenel, what it's going to do, it's going to look in the dog class for a function that takes in an attribute of type dog, right? So we look in the dog class for a speak function that takes in a dog. We don't find one. So we look in the animal class for a speak function that takes in a dog. Okay, then we're going to choose the function in the animal class. Okay, so this is what's kind of confusing about it, is that although in the dog class there is a signature that takes in an animal, and that would work, we want the best possible signature. So what we're going to do is choose the one in the animal class during compile time. Then during runtime, we're asking ourselves, can we do better? And we look in the dynamic types class, which is poodle, for the exact same method signature. We find one, so we actually return 4. Okay. Let me draw. Nice. Okay. So the next thing we do is poodle. We cast Sohum into static type poodle. Okay, so what's going to happen is over here, Sohum's static type for this call and for this call only will be poodle, right? And now we're also casting Benel into type poodle. Okay, so his one is also poodle. Okay, so what do? During compile time, we completely ignore the dynamic types. Okay, so what we do is we say, Sohum, your static type is poodle. Look in the poodle class for a function that takes in an instance of type poodle. Okay, so we find one that takes in a dog, right? So we go to the poodle class, we find something that takes in a dog, and since there's nothing that does better than this, we lock in on this method signature. Then during runtime, we say, hey, Sohum, were you lying when you said you can be casted into a type poodle? And then Sohum is like, yeah, I'm not actually a poodle, I'm just a dog. And then this throws an error because this is an invalid cast, right? So what's going to happen is this one will throw a runtime error. Okay, because Sohum cannot be casted to a poodle because his dynamic type is dog, and dog is not like more specific than poodle. Okay. The next one for fifth is we take Sohum, we say, okay, last time we failed, let's try to make you into a dog, right? So Sohum, right, now you're a dog. Okay, and then Benel still stays as the poodle. So what we do is we look in the dog class for a function that takes in a poodle, okay? We don't find one, so we look in the parent class, and then we lock in on this method signature right here, right? Because that's the best method signature we have, because we see Sohum is a dog, and we're looking for a function that takes in a poodle, okay? The next thing that we do is during runtime, we ask ourselves, can we do better? And since Sohum's static type is dog and dynamic type is dog, there's no like DMS. So we choose the signature we locked in during compile time, and we return 1. Nice. Okay. So for the next one, Sohum is still a dog because we did another cast, but now Benel is an animal. Okay. So what happens is during runtime or during compile time, we say Sohum, go to the dog class. We find the signature speak, right, that takes in an animal, but Benel is a animal, right? So that works, okay? So what we can do, we choose this method signature, then during runtime, nothing changes, so we get 3, okay? Okay, so the last one is we try casting Benel into static type poodle, okay? So what do is, okay, last time I forgot to change Benel to animal, but now Benel is poodle, okay? So we say, Benel, you are a poodle, and you're trying to speak to an animal, right? So we change Sohum's static type to animal. Okay, so what do? Benel is a poodle, so we look in the poodle class for a function that speaks to an animal. Okay, we don't find one, so we look in the parent class for the function that speaks to an animal, because Sohum is an animal. And then we lock in on this method signature right here, right? Because what we're doing is Benel is a poodle. We want to speak to an animal because that's what Sohum is. So we lock in on this method signature. Then during runtime, we ask ourselves, can we do better than this? And we can't, since Benel's static type and dynamic type for this function call are the same. So we return 3. Okay. Does anyone have any questions?
Can you repeat the reasoning for the 6th one again?
Okay, so we say that Sohum is a dog, right? And we're trying to speak to an animal, okay? And are we allowed to cast Benel to an animal? Yes, we are. Okay, so what do is we look in the dog class for a function that speaks to an animal, okay? And then we find one, right? And then during runtime, we ask ourselves, can we do better? And we can't.
Does it always runtime error when you cast an object as like a type that's like not as broad as them? Like will
Yeah.
it always, yeah, okay.
Yeah, it's always the case. Like if we ever do some like dumb cast where we try to cast an object to a type that's more specific than its dynamic type, then it won't work. Yeah, so like in this case, if we do this cast right here, where we try to cast Sohum into a type that's more specific than its dynamic type, right? We try to say Sohum, you're a poodle when you're actually a dog, it's gonna fail every time. In runtime though, because we only see our dynamic types during runtime. Okay.
So just to clarify, the casting type can be more specific than the static type, but not the dynamic type.
It could be more specific. Yes, yes.
Great.
Oh, it should be like, this thing should be intuitive, hopefully. Like the goal is if you guys keep doing more and more of these problems, if you see something like dog A is equal to an animal, there should be a small part of you that like somewhat dies because you're like, an animal isn't a dog. Okay.
So I have a question about
Yeah.
number 7. So during runtime, we were able to see that Sohum is actually a dog. So why don't we just go to the animal class and find speak dog method instead of speak to animal in the dog class?
Yeah, it's a good question. So we only really care about dynamic types if that's the instance that's calling the function. Okay, so when we pass in an object as a parameter, we only care about the static type of that object. So here, right, we only really like look at this cast to make sure it's an actual valid cast. Besides it being like a valid cast, we don't really care about the dynamic type of Sohum because Sohum isn't calling the function, he's merely a parameter.
Oh, so basically, as long as the dynamic type of the input of the function fit the description, that's okay.
Yeah, yeah, exactly.
Thank you.
Okay, any other questions?
So for the last one, we don't do poodles speak method. We do dog because dog is more specific. It has like the animal.
Yeah, exactly.
Thank
Yeah,
you.
you're welcome. Any other questions?
Do you have any like pointers for figuring out like when something's a compile time error and when something's a runtime error?
Yeah, so good question. The general like rule I like to follow is dynamic type errors or runtime errors mean something's wrong with the dynamic type. Okay, runtime errors really only come about because of like bad casts. Okay, so if you see some cast and it's bad, then it's usually a runtime error. Okay, and another way to like differentiate more rigorously is that a compiler is going to look at all of your code. Okay, when the compiler looks at all of your code, it only sees the static types of all of these objects, right? If it can detect any problem by only looking at the static types of the objects, that means it's a compile time error. Okay, some of these can include if you can't find the method signature, like looking in the static types class, right? We can figure that error because we know what the static type is. That's a compile time error. Yeah.
So for the method signature, if it like finds a method signature just like higher up in the hierarchy, it can still accept that, right?
Yeah, exactly. That's like classic inheritance. If we don't find the method we're looking for, we don't give up yet, we keep looking above. Yeah.
I had a question.
Yeah.
Why do things even have a static and dynamic type?
Yeah, good question. So it's oftentimes helpful for us to look at like certain objects as something with like a static type that's one thing and a dynamic type that's something else. Okay. One instance of this is if we implement some interface, it's really helpful for us to say we have a deck that's static type is deck and its dynamic type is array deck. You know, like a user of the deck class says, okay, all I'm getting is this deck. I know what a deck does. I don't really care if you're using an like behind the scenes array deck implementation or a behind the scenes linked list deck implementation. So a lot of times this does occur.
Oh, but so the dynamic type is just like we're specifying what this thing is.
Yeah, so the dynamic type is what the object actually is. Like in you guys' project 1B, you guys probably create some deck and then you say, oh, like I'm going to create this deck A equals new array deck, right?
Yeah.
Dynamic type array deck, static type deck.
But why don't we just set like static type and dynamic type to be the same thing always? Why don't I just say, oh, this has static type array deck and it's an array deck?
Yeah, good question. So like, let's say you're a user of this class. You don't like need to know all of the properties of an array deck, right? Life is so much easier for you if you only are given the deck interface and somebody tells you this is the functions that these are the functions you have access to, right? If you give somebody the array deck class, it's like, oh, like what is this weird circular implementation? I have no idea what's happening, right? It's much better as programmers for us to abstract behind the scenes things if we can. And
Okay, I see.
yeah.
Okay, cool. Thank you.
Okay. Is there? Okay. Any other questions?
Did you say that we would get to comparators today? Maybe
Yeah, I did. Okay, so I actually have a comparators problem. So whoever wants to stay, you guys can feel free to stay for the comparators question. If you guys want to head out, that's totally fine. So it's kind of a cool problem. I made it an hour prior to this. Okay, give me a second. I need to. Okay. Okay. Okay, I'm almost there. Okay, so we have a comparators question. Okay. So the idea here is our class DMS is now a comparator, okay? And how it's gonna work, it's gonna be comparing animal instances, okay? This is like a kind of a tricky question, so try to understand. We're gonna be comparing two animal instances, which may have differing dynamic types, okay? We're gonna say an object is like higher than another object if its dynamic type is farther down than the other dynamic type, okay? So I have some examples. If we say that we have like a dog is greater than an animal, a poodle is greater than an animal, and a poodle is greater than a dog, okay?
1, 1, 1, right? Shouldn't all be ones.
Say that again? Okay. So things that are the same, dogs, like if we both have dynamic type dog, it's the same. If we both have dynamic type poodle, it's the same. And we both have dynamic type animal, they're the same, okay? So you guys need to implement the DMS is now a comparator. What does it mean to be a comparator? Every comparator, ready, watch this, this is cool, right? IntelliJ is like, hey, you claim to be a comparator, but you don't implement the methods, okay? So then IntelliJ adds this method in here for us, okay? So it's IntelliJ's way of like telling us that we're bad at programming, but we already have this compare, okay? So what you guys should be doing is in this method, you only have 2 lines to implement in code, okay? You guys should be returning 0 if the objects are equal. You should return any positive number if the first object is greater than the second, okay? That's just how compare2 works, okay? Compare says I'm taking in this object and I'm taking in another one. If O1 is greater than O2, then we will return a positive number. If O1 is less than O2, we will return a negative number. If O1 is equal to O2, we return 0, okay? And you might be wondering, like, how do we define one object being greater than the other? In this instance, we say an instance is greater than another instance. It is if its dynamic type is more selective than the dynamic type of the other object, okay? So you guys, using your DMS skills, will add equality checks here such that you figure out if they're equal or if the first is greater than the second, okay? It's kind of a puzzle, so take some time and think about it. Okay, so let's go over the solution. For this check, we want this check to give us true when the objects are equal. Okay, so what are the cases when the objects are equal? Okay, so we can either have, right, we both have either both are animals, both are dogs, or both are poodles. Okay, right, these are the cases. So my first idea is like, what if we say returns if first is equal to second? Okay, will this be enough to tell if the both objects are equal or have equal dynamic types? So take a minute. Is this enough for us to determine that the dynamic types are the same? Okay, that's enough time. So does anyone want to be brave and shout out an answer?
No.
Yes, it is not enough. Do you want to give a quick explanation?
Because it just checks if the bits are the same or if they're pointing to the same thing.
Oh, okay. So not entirely. It's because first and second are going to be the return types of executing these functions, right?
Oh, right.
Okay, you got the correct answer though. It's not enough, but okay, I'm just going to give you guys a solution for the sake of time. So in order to prove that this is not sufficient to tell if the dynamic types are the same, I could just produce a simple counterexample, right? So let's say that we have an object of, let's say O1 is equal to a dog, and let's say O2 is equal to a poodle. Okay, so in this situation, what does O1.speak animal do? We go in the animal class, we lock in on the method signature right here, right? Because we're trying to speak to an animal. Then during runtime, we choose this one, okay? And now what does O2.speak, right? What does this one do? So what is O2? O2 is an animal. We go up here, right? O2 is actually a poodle, but poodle's dynamic class doesn't have this exact same method signature, but we still do dynamic method selection because we would rather choose this one, okay? So in the case that O1 is a dog, O2 is a poodle, O1.speak animal is the same as O2.speak animal, in which case this check is not sufficient, right? So this actually took me a while to catch. This was my first idea. I'm like, it's simple. And then I was like, oh, wait, it doesn't work. Okay, so we need another check. And the other check, there's many possibilities. One way is we can just make sure that when you call O1.speak dog and O2.speak dog, they are the same. Okay, so that's going to account for this edge case situation that we're missing, because when we do O1.speak to a dog, we lock in on this method signature, and then during runtime, there's nothing in the dog class that's better, right? So when we do O2.speak to dog, we lock in on this method signature during compile time. During runtime, we look in the dynamic class, which is poodle, and we see something better. So we account for this situation, okay? Right? So the next question that arises is, how do we know if first is greater than second? Or how do we know if O1 is greater than O2? Okay, well, let's look at the different cases. What can O1 be? O1 can be poodle, right? And the other one can be an animal, right? So let's just say the pair poodle animal is okay. Okay, other pairs that work here, right? If we have maybe poodle dog, that's valid. Or if we have dog animal, right? These are all of the possibilities in which O1 is greater than O2, okay? So our if check just needs to account for these three cases, right? If O1 is a poodle and O2 is an animal, we want to enter this if condition. If O1 is a poodle and O2 is a dog, we enter. If O1 is a dog, O2 is an animal, we also enter, right? So the next question that arises is, how do we know, like how do we account for these situations? So if you notice, if O1 is a poodle, it has to be greater than O2 because O2 cannot be a poodle, because if O2 was a poodle, we would have returned a 0 here, okay? I'm going to say that again. I can add a check here. If O1 is a poodle, we know for a fact that O1 is greater than O2 because they can't be the same, right? Right? That's pretty cool. So how do we know O1 is a poodle? Well, what's something only poodles do? Something only poodles do is when you call O2, like when you call this function right here, O1.speak to a dog, only a poodle has access to this function, right? So what we can do, if I say third is equal to 4, this is saying that O1 is a poodle, right? Because nobody else, right? Dogs can't call this function, animals can't, and we know a poodle can because during compile time we'll lock in here, during runtime we choose this one, right? Okay, so we've accounted for these two cases. The only case we need to account for is when, right, O1 is a dog, O2 is an animal. So to account for this case, how do we know something is a dog? We know something is a dog if when we call O1.speak to an animal, it chooses this function right here, right? So if first is equal to 3, this is telling us that when we called O1.speak to an animal, we chose this function, right? That will only happen if the object is either a poodle or an animal, right? And we know this check accounted for poodle, so if we ever entered here, it means it has to be an animal, okay? Oh, it has to be a dog, correction. So, right, first must equal 3. This is saying the instance is a dog. Now, in order to check that O2 is an animal, what can we do? Okay, I'll leave you guys to this one. How do we know that O2 is an animal?
Does it return 1, just like a shot in the dark?
Sure, yeah. So if I say second is equal to, right, second is right here. If I say second is equal to 1, right, what this is saying is that when we called O2.speak to an animal, it went here. Oh, 2, my bad. Okay, close. Okay, so when we called dots, right, if O2 is an animal and we speak to an animal, right, we go in animal, then we choose this signature, right? And that makes that we know that O2 is an animal because in the case that O2 happened to be a dog or a poodle and we executed O1, or we executed O2.speak to an animal, it would have chosen this signature, right? Since it returns 2, we know for a fact that O2 is an animal, okay? So that's a really tricky problem. No worries if you guys didn't get it. Hopefully it does make sense now and you guys could like think of this logic in the future. Okay, so we have a lot of questions. Okay, so, yeah.
Sorry, I have a question for the larger one. So why couldn't we draw directly like first is larger or equal than second, and the third is larger or equal than fourth?
Can you say that again? Sorry.
Yeah, for the like a larger, the first is larger case. why we just write the condition as first is larger or equal than second, and third is larger or equal than fourth.
So yeah, there are like many solutions here. So that could work. In the beginning, I preface this by saying like there's many ways of doing this. For me, this was like the intuitive way of thinking about it. Like I think that solution could also work. I'd have to verify, but I'll send you this file afterwards if you're part of the email group and you can check.
Okay, thank you.
Okay. For other people, any other questions?
Do you think you'll record the answers to the rest of this exam prep worksheet?
Yeah, I probably will.
Because I feel like you're the only one who has exam prep.
There's a few more exam prep people.
Okay.
Yeah, actually, I'll ask them if they're gonna do the second question. Then we can ask one of them to record. I have a busy week, so yeah. We'll see. Okay. Any other questions? Yeah.
Yeah. I was just wondering, okay, so like this comparison works when we have animal, dog, and poodles, right? But what if we start having more subclasses and I don't know, it becomes messier and we don't have like ways to check all the time for first and second and third by making calls to the methods? And what if we didn't even know what methods were in our subclasses?
Okay. So this is not the optimal way of comparing objects. There's like better ways of creating objects. You can use the get class function. The reason I wanted to like give you guys this maybe not intuitive way of comparing objects is so you guys can like make sure you guys understand dynamic method selection.
Yeah. I was just wondering, like, if we wanted to make it general, how would we go about it?
So look into like the get class function. That's like a good way of checking the dynamic type. Yeah, good question. Any other questions?
Why could you not just do like dot equals? Would that not work?
No, actually, yeah. So tough question. So if we do like if, oh no, O1, okay, O1 dot equals, right, O2. So in the current situation, if we have like two objects, like let's say we create, I don't know, like animal A is equal to a new animal, and then we create another. Okay, let's say we create two of these people. Okay, and if we do A dot equals B, since we have not overridden the equals function in the animal class, it won't think that A and B are the same because they're different instances. Do you see that? The only way that A dot equals B will equal true here is if, right, we implement dot equals or override. That's my bad, wrong word. Okay. Does that make sense?
Yeah, so dot equals would only return true like if they point to the same object, but since your A and B are different objects, it won't.
Yeah. And yeah, I mean, if we did have an equals function, I'm gonna use the line of reasoning I used with Paola, I might mispronounce it, but this problem wasn't meant for like, wait, go for it.
Paola.
Okay, I got it for the future. Okay, yeah, this problem was just meant for DMS. It's not meant for like an intuitive explanation. Like you're not gonna do this in the future probably, just for this function. Okay, so many people disliked the DMS. I thought it was cool. Okay, other people, like questions on this?
Normally the comparator questions on exams would kind of be like this, right? Like you kind of have to figure out, what the comparator is returning.
Yeah, so a comparator question would say like, we'll take into like, maybe we'll make it generic and we'll make a T here, right? So we'll have to like specify, but okay. So in like an exam, you'll probably take in like, if there was a compare function, it'll probably take in two instances, and then you have to specify some way of comparing them, okay? So in this case, it happened to take in animals, right? If we're comparing integers, we could put that here. If we're comparing, I don't know, a generic, we could put that there as well, okay? Yeah, does that make sense?
Yeah.
Yeah, it's not too bad actually. I think comparative questions are like this question is just like hard for a different reason because we use DMS. Like the comparator itself isn't like the crux of the difficulty. Yeah, I hope. Yeah, this question is really hard though, just because you have to like think of so many different cases and like what happens in dynamic method selection for this and that. So it's definitely tricky.
It was good though.
Nice, nice. I'm happy.
I
You
think
wrote this right before.
Oh, say that again?
You wrote this right before discussion.
Yeah, in the hour. It was
uh,
Wow.
stressful. It wasn't working for a bit and then I was scared, but we pulled it together. Okay. Other questions? Nice. Well, I'll be here for a bit. If you guys want to leave, that's totally fine. If you guys have like other questions, I know you all have questions. It's like the 2 days before midterm. So feel free to ask. I'm going to stop this recording.